So now that we've seen from simple dynamic analysis that the encryption here actually contains repeating binary strings when I put in repeating 16-character data as input in the password. So now we want to find out exactly what kind of encryption they're using. And that turns out to be extremely easy. Notice this string name, encrypted password. That's language that came from the app. And it turns out all you have to do to reverse engineer this app is go into the directory. The APK file is how an app appears, and I put it here in app.staples. All right, -2, I think. All right. So what I've done here is the APK tool within a directory above here, and I've unpacked the APKs. I've unpacked it with APK tool. It just unzips like a zip file, and then you can look at the source code here in Smalley. And you can look for interesting things, like I can look for this string, which I know must be in the app somewhere, encrypted password. So let's look for that in subdirectories, and you will find that it appears 4 times in the same file, and this is the file, app staples mobile CFA, ke.smalley. Now that means I have an entry point into understanding this app that's very easy. This is the structure of the app. These are the Android is the libraries that came from Google, and here's libraries from somebody else. This is the part Staples wrote. Notice how parts of it have turned into A and B, and AA and AB. This is the worthless product called ProGuard that comes with Android Development Studio and does nothing to secure your app, but it seems to fool some developers into thinking that reverse engineering is now difficult, because see how my methods here are just A, B, C, D, E, F, and they say, oh, how will anyone figure out which one of these contains the goodies? Well, since the variables inside there are not hidden, as you just saw, it's very easy to find the goodies, even though that file is called e.smalley. And that file called e.smalley refers to another method, which refers to another method, and eventually leads me here to a.smalley, where here is this thing called capital M is the thing that creates the encryption key. And it takes this string, extra salt, and it adds it to another string, which is created from just some device parameters. Then it runs it through SHA-1, and that's the encryption key. That's really all there is to it. So what you do, to verify it, I modified the app. This is another crazy thing. Staples should not allow this app to run on a rooted phone. Nothing financial should be allowed to. And even if they do, they should verify the integrity of the app before it connects to their server the way the NFL app does. But since they don't, I can actually modify the app, re-sign it with my own key, and run the modified app on the phone. And that's what I've got in here. It's going to put log entries in there that use the word Trojan. So I'm just going to stop the app. Staples, let's force stop, and then I'm going to monitor the log, which should be here, exit from that, and adb logcat. Now you see a lot of messages going by from the phone, and to make it easier to read, I'm going to grep that, Trojan, so I see only the Trojans that I've added. And there you can see from previous launches, the Trojan is in the memory here. This is what it looks like, extra salt, and then a series of parameters that come from the phone. And I wrote up instructions for this to give it to my students for homework, since the company obviously does not care to fix their product. They will be used for homework. And so if you look here, here's where it actually encrypts the password and writes out that information. And it does it by calling 2 functions, GU and M, and the GU is the thing that generates the encryption key. And what it does is it gets the brand, the device name, the model, the serial number, and then the name of the package, puts those things together, and then adds extra salt in the front, and that's the key. And you can verify that, because if you take this mesh, which contains just a series of things that are easy to retrieve from the phone with simple command line commands, then you can go and SHA-1 that. So you put in all that junk here, cache it with SHA-1. Now that creates a 160-bit hash. And you need the first 128 bits of it So you take the whole thing and remove 1, 2, 3, 4 bytes. That is the AES key. And you can prove it by going here, and I can just put in my key, which was 2, 4, 5, 6, 7, 8. 1, 2, 3A. That's the password that got encrypted. The password's in plain text. Here's the hexadecimal key. Now that's the extra salt, so my copy here did not work, which seems to be a common problem with Chrome these days, that when I copy with logo C, it fails to copy. Anyway, there's the hexadecimal key, and if I encrypt with that hexadecimal key, I get 057EB9, and if you remember from the previous video, that's it, 057EB9. I'm now able to completely reproduce the encryption, and therefore I can take somebody else's phone and reverse the encryption and steal the password from the data they stored on the phone, and given the password I can log into the website and steal information about their credit card, although I was only able to get the last 4 digits and brand of a credit card because they have the sense to implement defense in depth. So Staples, rather than making credit cards stored entirely in there, have limited the information you can see about them, which is a very wise move if they are going to have people write such miserable apps that gain access to your account. It's a good idea not to trust people even if they can log in. But anyway, I wrote a homework for my students, and if you like, you can then steal the credit card out of my account at Staples from this information. Here's the stored data on the phone, and here's just a few commands that get the information off the device, like the brand and serial number and such. So that's what I wanted to show you. Staples has made an app that is easy to reverse engineer, and the lesson is don't make up your own cryptography. Instead, read the manuals and learn how to use a standard solution you can trust, like the Android keychain.